Hi math class, we're starting our new unit today. It's polynomial functions. All right, the next 3 or 4 units are all types of functions. I've mentioned get your hands on a graphing calculator or at least an emulator on your phone or laptop. A good emulator is Wabbit Emu, and I'll put a link or description in our Google Classroom stream. All right, so let's talk about polynomial functions. They have terms separated by positive or minus signs. There's only one variable, and that variable has to have whole number exponents. Okay, so what I've done is listed a bunch of examples here. So you've probably seen this before. I know some students don't like f of x. You can think of that as just y. So this first one's just like y equals 3x plus 1. And that's what you put into your calculator. You'll see later in the unit that there are benefits to putting f of x. But for now, if you want to think of it as y, totally fine. So I've got 5 examples here. F of x equals 3x plus 1. You call that a linear function, and that just means it's a straight line. So if I sketched it, it'd look like this, or like this. 3x plus 1 would look like this one. We have a positive slope. All right, the second example here is just f of x equals a number. You call that a constant function, and the graph is just a horizontal line. Okay. This guy here, this is an example of a quadratic. And what you're just seeing is that there's terms separated by plus or minus signs. It's only one variable, so x, and whole numbers as exponents. Quadratic functions are parabolas. They can look like this or like this. Okay, fourth example is a cubic, which means it has a power of 3. Those can look a couple different ways as well. Generally like this or like this, but we'll see different examples where you might not actually have this up-down motion, but that's a good visualization there. The last one's kind of wacky, but I want to just show you. This is a polynomial. There's a fraction, but that's okay if it's the coefficient. There's a square root, but it's okay if it's just numbers underneath. The x's have whole number exponents. This decimal, again, if it's just a number, that's fine. Now I want to show you what aren't polynomials. So these are not examples of polynomials. Any variable in the denominator is no good. This guy, you can't have a fraction as a power of x. You call that a radical. And it's actually the same thing as having a square root. I want to point out that this is different than example 5. You can have a number under a square root. That's just the coefficient. It's okay. You cannot have x under a square root. Another example I'll just add here quickly is you can't have a function of 2 variables. So if you see like xy plus 1, that's not a polynomial. Okay. I don't think I'm going to try to confuse you with that, but it's good to know. Okay, next thing I want to tell you about, it's a simple idea. It's called degree, and degree helps you understand or recognize the shape of a graph. I kind of sketched some on the other side of this page. You'll need to be able to determine degree really quickly when looking at an equation, and it's just the highest power of x. So here's some examples. This guy, there's a 3 on the x, that means degree 3. I tried to fool you on this one by putting the highest power second, but that's its degree. It doesn't matter that 12x comes first. This is a degree 2. This guy, I tried to fool you again by making it 4 squared, but that's just a number, that's 16. The degree is the highest power of x, which in this case is 1. When you have a constant function like this, just f of x is a number, that's a degree of 0. And you might think that's weird, but just remember, anything to the power of 0 equals 1. So this is like saying 5 times x to the power of 0. 5 times 1.